This video is prepared by Group 1 and this is about logic simplification using EVM and implementation using 74LS151 8-to-1 multiplexer IC. For the first question, with A as the entry variable for this Boolean function, obtain the simplest Boolean equation using EVM. By looking at this Boolean function, it consists of 4 variables which are A, B, C, and D. Therefore, it will have 16 combinations which is equivalent to 2 to the power of 4. This Boolean function is the sum of minterm at the entry of 1, 2, 3, 6, 8, 9, 11, and 12. Therefore, at the entry of 1, 2, 3, 6, 8, 9, 11, and 12, the function will become 1. Meanwhile, at the remaining entries such as 0, 4, 5, 7, and 10, the function will become 0, which are product of max term. Since A is selected as the entry variable, therefore the function will compare with A. When B, C, D are equals to 0, 0, 0, functions are equals to A. Therefore, EVM is A. When B, C, D are equals to 0, 0, 1, both functions are equals to 1 regardless to A. Therefore, EVM is 1. When B, C, D are equals to 0, 1, 0, the functions are inverse to A. Therefore, EVM is complement of A. When B, C, D are equals to 0, 1, 1, both functions are equals to 1 regardless to A. Therefore, EVM is 1. When B, C, D are equals to 1, 0, 0, both functions are equals to A. Therefore, EVM is A. When B, C, D are 1, 0, 1, both functions are equals to 0 regardless to A. Therefore, EVM is 0. When B, C, D are 1, 1, 0, both functions are inverse to A. Therefore, EVM is equals to complement of A. When B, C, D are equals to 1, 1, 1, both functions are equals to 0 regardless to A. Therefore, EVM is 0.
Okay, after we have finished the truth table, then we can draw 3-bit K-map to get the equation. From this K-map, we can see that B shows the rows, C and the input shows the column. Then we can input the EVM from the truth table into this K-map. According to the sequence, starting from 0, 0, 0, we can input A, 1, A bar, 1, and then A, 0, A bar, and lastly 0. We can also substitute 1 with A plus A bar. In order to get the equation, we should find the same value and circle it. So to like this, blue circle A, and then the green A plus A bar, and lastly A bar. So to derive the equation, we'll start with blue circle, occupies both rows, so we don't have to mention the row, and add column C bar and D bar. So the answer A, C bar, D bar. The green circle is at 0 rows, which is B bar, and then add 0, 1 column and 1, 1 column. So as 1 is on both right side of the column, so it should be D. So the answer is bracket A plus A bar, bracket B bar, D. And lastly, the right circle occupies both rows too. We don't have to mention the rows. And add 1, 0 column, which is C, D bar. So the answer is A bar, C, D bar. So the final answer should be A, C bar, D bar, plus B bar, D, plus A bar, C, D bar. So that's all. Thank you.
Question 2. Implement function FABCD using 74LS151 8-to-1 multiplexer IC only. Assume input A and its complements A bar are available. Okay. This is the truth table for 8-to-1 multiplexer. In question 1, we are asked to use A as the EV. So in this case, BCD will represent S2, S1, and S0 respectively, and F will be the output. So this is the circuit diagram of the 8-to-1 multiplexer. It has 8 inputs which are from I0 to I7. It has 3 selects from S2 to S0, and it has 1 output. For example, when BCD are all 0, it means that S2, S1, and S0 are all 0. The input selected will be I0 and it will be output. Okay. So similarly, when B, C, D are all 1, it means S2, S1, S0 are all 1. The input selected will be I7. Okay, now, so the table in the right is the table that my colleague did in previous question. Okay, I have labeled it I0, I1, I2, I3 till I7 here to indicate that for the first EVM, it is actually in I0 or the first input. The I1 is 1, I2 is a bar, I3 is 1, and so on and so forth. Okay, so for example, when B, C, D are 0, okay, the EVM will be A, right? And you can see here, when B, C, D are 0, the first input will be selected. This is the first input, so it will be output to F. So the first input will be A. Similarly, for I4, it will be 1, 0, 0. The BCD is 1, 0, 0, and the output will be A. So this is I0, I1, I2, I3, I4. This is the I4, and it will be output, okay, when B, C, D are 1, 0, 0. Okay,